Okay. Okay. Yikes. Yikes indeed. Man, I haven't gotten off the ground yet. Alright. Let's man, I'm so sorry, dude. I don't mean to be like I'm hoping for. Now there are 2 shutdowns, I know. I don't disagree. Okay. Yay! Let me just put my hand here. Yeah, okay, good. Let's try. Hopefully this works. Hopefully. Okay. So, so to answer your question here, let's go ahead and plug in the numbers here that I put up here earlier, and we're going to find out what we get here. Okay, Fernando? So, I still want to finish this problem irrespective of that fact. So we get 1,000. Oh, whoops. That would be, well, that'd be a problem. Give me a second here. Just trying to figure out what we get here. I'm gonna wonder why. It's like, oh, why did I get such a large number? That doesn't make sense. Okay. So here we get for the annuity, we get 41,645.91. Now we just compare the two. We want to subtract 66,000 from the 41,000. So minus 41,645.91. So I'm just going to subtract the two. And so here we get, come on, 66645.91. 1645.91. All right, so we get $25,000 of difference here. So your final answer here will be $25,000. Yep. Okay, good. All right. Sorry for the long wait there. I do apologize about that though. But the correct answer here was for this problem here was $25,000. So you just found the value between the two, then make a subtraction there, and then got that good to go. Okay. Any questions about that? Refresh again. It's doing good so far. It's doing good. It's doing good so far. So far so good. Reloaded. Perfect. Okay, nice. Nice, nice, nice. Okay. Man, no matter, man, I seriously will just have to call Comcast and see if they just can fix the connection, make it secure. Like, it's just stupid that I've had this problem for ages now. It's just like, oh, we'll do something. And I'm like, yeah, I guess you will do something eventually. Like, never. What makes me a sad banana? Hey, look at that. That makes me a sad banana. All right. Any more questions before we move forward? Gotta do real stuff today. Hey, yeah, it's true. Can we do the second part? Oh, there's a second part to this. Let me see. After 25 years, how much more interest will be earned from the lump sum investment from the annuity? Interest from earned on the lump sum investment will be approximately blank. Okay. So all you have to do is figure out how much interest that you have earned. So from the first one, all you have to do here is take the amount that you made from the lump sum and subtract it from the 25,000 that you got there initially. Because basically everything else after $25,000 is going to be interest, on top. You're going to do 66, 645.91 minus uh minus 25,000. Let's take a look at what we get here. So we get 41,645.91. And then we do the same thing here with the other one here. We have 41,645.91. And we'll subtract 25,000 from that. Again, the reason why we subtract 25,000 is that's how much we deposited in this periodic deposit. We just put in $1,000 every single year. Okay, so if we subtract that from 25,000, we get 16,645.91. And if you subtract these two values from each other, all right, if you subtract these two values, the 41,000 and the 16,000, you're just going to end up with 25,000 here again. So the difference here, in this case of interest, will be $25,000 as well. Yep. All right. So that's the answer to that other part there. And that's how we can basically suss it out. Okay. All right. Any questions about that, Fernando? Hopefully that makes sense. Wow. 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 Okay. Any questions at all, Fernando, Neon? We're going to get started here in just a second. So I'm going to be sure that you guys good with that. Got nothing? All right, fair enough. All right. Okay. So let's go ahead and get started here with the new material here for today. Today we're going to be doing section 12.1. All right, so section 12.1 here is going to talk about we're going to talk about statistics here in chapter 12. Okay, chapter 12 is the last chapter here in the textbook. All right, do understand that after chapter 12, that's it. That's the class for the most part. Remember that we will not have a final for this course. So the last test is basically the final test, essentially. Okay, so section 12.1 talks about sampling, frequency distribution, graphs. Okay, so let's talk about sampling. Yeah, let's do it. All right. So in statistics, okay, what we want to do here is if we want to do a statistical analysis, let's say you do like a presidential poll or something like that. If you do a polling of some variety, okay, regardless of whatever that polling is, all right, maybe you're like, okay, I want to pick some people, I don't know who those people are, but I want to be sure I get a good cross section of the population to see who people support, either, their respective candidates. Okay. So let's talk about here what this random sample is. If I'm doing like a polling thing, like I mentioned here in the example here, a random sample is a sample obtained in which every element in the population has an equal chance of being selected. Okay, now there are a few things here in this definition that we will have to kind of get to know. First of all is population. Population is exactly as it sounds, like a giant, like the large group of people or a large group of items. Okay, that would be the population. Okay, so a large group, okay, of items. Okay, contains all the people or all the objects. So okay, so for example here, everybody at Harper College, for example, is going to be a population if I wanted to just ask people within the college. All right. Next, I have, again, a sample. A sample here is a subset of the population. So maybe if instead Harper College could be like, say, all right, wow, Harper College is the population, but maybe I pick uh, a class, okay? Maybe I pick a class within Harper College, your class, and I say, okay, this class here is my sample. I'm going to choose you guys here as being in the sample, all right? And again, random sampling here is basically everybody has a chance to be selected here. So let's say I want to ask campus-wide, and I ask you, hey, do you like candidate A, candidate B? You give me your answer. You have an equal chance of being selected as much as the person clear across campus, okay? There's no rhyme or reason why I'm choosing you. There's no bias involved. I'm just be like, hey, here you go. I just ask you a simple question. I mark it down. There you go. Maybe walk around campus a little bit more and just ask some more questions here. Okay, that's basically all I'm doing for the most part. There are types of sampling as well. There are types of sampling that we do have to talk about. So let's talk about types of sampling. Okay. Now, if we discuss types of sampling here specifically, there are certain types of sampling that are important. All right. Let's discuss about certain types of sampling that are important here in order to get a good cross-section of people or objects, to do your test over. All right, so the first type of sampling here There's several types here, but we can talk about that. There's things called, besides random sampling, there's a systemic sampling. All right. So systemic sampling basically is, well, actually, you can say systemic, or this is also called stratified sampling. Well, I guess I could call it systemic sampling. Systemic sampling is that you have a system to decide on the sample. Okay? So you have a system to decide on the sample. So let's say you have a group of people and you pick like every third person. So you choose every third person starting from someone. So maybe you randomly choose a person. You're like, okay, after this guy, I'm just going to go ahead and pick every third person after this guy, and I'll be good to go. All right, I don't care. All right, every third person, good, fine. All right, I can do that. All right, so that's systemic sampling. There's a stratified sampling. Stratified sampling is you choose a sample based on categories or characteristics. So you basically like saying, okay, male and female, for example, you're like, okay, I'm going to pick X amount of males, again, random, X amount of females, random. Again, I could have 50-50 if I'm picking a sample of 100 people, and then I go ahead, put it together, and be like, all right, that's my sample. Fine, I got 100 people, perfect. All right, not too hard as terms of a concept, but it's just like, okay, this is how I'm going to go ahead and put it together. That's fine. That's that's something that you can certainly do. It's really not too hard. Um, let's see. There's also let's talk about something that's also realistic, and let's talk about sample of convenience. Okay, so let's talk about what sampling of convenience means. Is essentially you choose your sample of what is most convenient to do. So let me put it in this sense. If you have a survey that you want to take, you don't want you want to be able to stand in one place and then ask people. That's why most people stand in one place. They'll ask people like, "Hey, do you want to take my survey?" And then you would say, "Okay, yes or no, I want to take your survey. That sounds like a good idea." But you're not going to run clear across campus and you're going to say, "Oh, I want you to take my survey," and then run clear across the other side of campus and say, "Hey, I want you to take my survey." Although they're equally likely to be selected, while that's true, it's probably not in your best interest to run around like a chicken with its head cut off. It's probably a lot easier for you to, be a little bit lazy about things and be like, you know what, I'm going to probably be a little bit more convenience here. I'm not going to run around, too much and grab, get what I want. So there's certain things that, certain other types of sampling here, like sample of convenience, that can certainly be taken into account. All right. So those are a few types there that are types of random sampling that are often commonly done here. Now, of course, with those random samples, of course, we do get certain things here. Now, these are types of samples that you see. There are other types, by the way. There's cluster sampling. Um, there's a free response. Forget what we call that again. Yeah, free response sampling. Got to be careful about the free response, but there's other types here that you can certainly talk about. I'm not going to get into that too much, but you get the general gist. Okay. All right. Now, what do we want to do with these samples? Okay, we're going to take a group of 200 people, maybe 100 people. We ask them a question. They say yes or no. Maybe they categorize themselves, whatever. Maybe I ask them their age. Okay, they say, okay, I'm 37. Okay, and they I mark that down on my sheet here. Okay, I asked people their age is 37. They maybe go into a category of some variety, okay? Maybe you're just trying to break down data as much as possible. And that often happens. Now, what we want to do here specifically is we want to look at something that's called a frequency distribution, okay? So let's talk about what a frequency distribution is. A frequency distribution is a way to basically organize your data. A way to organize your data. A way to organize your data um, based on categories. So we may have categories of some variety. Now, of course, in order for us to get these categories, you take a collection here. You collect data items. What data items here basically are data that is collected during your study/survey. So maybe again, I can go ask, I basically, example here is to get someone's age and add them, basically get someone's age. Maybe that's a data item that I could use. We could say that. A frequency distribution here basically takes this category and puts it into a numerical aspect, okay? So it basically, frequency distribution, let's talk about the key here. A frequency distribution, basically all this does is essentially categorizes data items and then what we'll call classes, and then counts how many data items fall into that category or class. Okay. All right. Are there any questions so far, by the way? Any questions so far? I know we haven't done like an example here yet, but want to be sure that I'm not like throwing this info at you super fast. So Fernando Neon, no. Yeah, I know your brain hurts, but it'll make a whole lot more sense once. Don't worry about the vocabulary too much. I'm not going to be stressing on that here. Most of that is just to set you up for what the practical examples are. So the vocabulary is one thing, but we're going to do a little bit of more vocab, but we'll go ahead and apply it once we look at an example, okay? And then it'll make a whole lot more sense. All right. Okay. Now that one's actually a little. Okay. So let's talk about some of the keys here. Now, before we talk about some of the keys here, though, let's go ahead and take a look at an example here, as I kind of mentioned here before. So my example here is we're going to have a data set full of items. Let's say in this case here for you guys, let's say they're test scores, okay? Random test scores between whatever to, up to 100, whatever. So I'm just going to write down just a random set of numbers here. Okay, no crazy stuff, trust me. So let's just try this. Okay, so let's say this is our data set here. Okay, these are the scores that we effectively just went ahead and recorded down for, let's say, a bunch of students here in a class. Okay, so let's go ahead and take a look here and see how we can put this into a proper frequency distribution. Now, inside a proper frequency distribution, what we're going to have is we're going to have a few columns here. Okay, we're going to have two columns here specifically. We want to be able to organize this data as easy as possible so we don't have to really worry about, making it too hard on yourselves when maybe we want to go ahead and use it later on. Now, as I mentioned here, we talked about categories and classes. Now, since this is a testing kind of scenario here, let's think of it from a practical point of view. From a practical point of view, we think of the same things as, say, like ABCDF. Okay, we think of it like a test score, kind of like that. And ABCDF could be very valuable, is certainly also applicable as classes. Well, which papers got A's, which papers got B's, which papers got C's, D's, and F's. Another way to look at this is let's go ahead and put in a small little table here. I don't know how many of these I'll need, but I'll need some of these. All right. Here. All right. Okay. So what we're going to put here is we're going to go ahead and put the test scores here. All right. Remember that the test scores here is your class. Okay. Now I'm going to make some notes here in regards to the class here in just a moment. And basically we're going to put the frequency over here. The frequency again reflects how many of those data items, i.e. test scores, fall within that range. Now let's say we go from, top to, let's say we go from bottom to top, okay, going up in ascending order. Now, let's answer this question here really quick, okay? What do we do here in this case when it comes to test scores here? What's a good way to take a look at this data set? All right, data set is just a set of data items. What are we to look at this data set here? How can we break up these scores here appropriately? What do you think a good idea would be? If we were to use if we can't use A, B, C, D, F, okay, but with numbers, how could we kind of split that up? What would be the easiest way to kind of do it if you were to sit and think about it for a second? What's the okay, really quick, what's the lowest test score you see in that data set? All right, 44. That's right. 44 is the lowest test score here in this data set. Totally agree. So maybe if we talk about a class here, we want to talk about a class here, you're like, okay, what about all scores? Be right back, going to the bathroom. Come on back quick. Got important stuff to talk about here. So if we talk about test scores here, then maybe we want to pick scores in the 40s. Now, let's say I choose 40 to 49. Okay. Now there's a couple things that we need to talk about here specifically regarding classes. Okay. Note. All classes must have the same, and what we're going to call the same class width. All right. What does this mean, the same class width? I.e., they must be consistent. Okay. So they must be consistent. Let's talk about what this class width means. I know this is, again, a lot of information here, but let's talk about that. There are two parts when it comes to a class, like 40 to 49. The bottom part of the class, which is 40, is what we call the lower class limit. So the lower class limit is the lowest value in a class or category, and the upper class limit here is the highest value in the class. So, for example here, the lower class limit between 40 to 49 would be 40, okay? And the upper class limit between 40 to 49 would be 49. Okay, so that's the highest value we can get. That's the lowest value we can get. It just depends, of course, on the class here. Now, I did say that all classes must have the same class width. Now, why did I define lower class limit and upper class limit? Well, this is where class width is going to come into play. So, class width, the way you can actually mathematically figure that out is you take the lower class limit of class 2 minus the lower class limit of class 1. All right, now you're probably, man, I know this is a lot of stuff here. Okay, let me show you what I'm talking about here, and then it'll make it'll make a bunch of sense, okay? If I looked at 40 to 49, okay, what would be my next category or class? What would be your next category or class after 40 to 49? A little bit. We're just talking about classes and categories, okay? So my question is that if 40 to 49 was our first category or class, what would be the next class? What would be the next class up? What would be the next class up here after 40 to 49? What do you guys think? Think about it, guys, for a second. What would be the next category after 40 to 49? All I want is just a logical answer here. That's it. That's actually correct. 50 to 59. Logic is just common sense, right? 50 to 59 here would be your next category up. That's correct. So you have all the scores in your 40s, and then you have your scores there in the 50s. Okay, now think about it this way. Lower class, basically class width is lower class limit of class number 2 and lower class limit of class number 1, i.e. the lowest value in each class. Imagine, if you will, this was class number 2 or category 2, and this was class number 1. So in this case here, you just take the lower class limit, which is 50, and you have to take the lower class limit, which is 40. So all we have here is the class width here specifically is going to be equal to 50 minus 40, which equals 10. So what am I saying here? The note here, all classes, and let me zoom out here for a second. So all classes must have the same class width. That must be true. Okay, fine. We're going to go with this. All classes must have the same class width, all right? And that has to be 10. So that has to be the difference here. So notice here, how many scores in the 40s do you have in this first class? You have 10, 40 to 49. 50 to 59, you have 10, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59. You have 10 scores in the 50s category. And you could just continue moving up here. So when it comes to a frequency distribution, you're not allowed to kind of pick and choose what those categories are unless they are consistent. So I can't just be like, okay, let me pick, 50, and then let me pick 53 to 57 as my next category, and and so on and so forth. I can't mix and match. It has to be the same consistent width for every single category, okay, regardless. Okay, so that's kind of the tough part there to kind of get. But once you get that, you're like, okay, that's not as bad as it may seem. All right, this I promise you. It's not as bad as it may seem. All right, any questions so far? Hopefully that's a little bit more clear. Okay, now let's talk about what we want to do next. We want to talk about frequency here, okay? So if we talk about frequency, that's just dependent on how many scores are in each category. So how many scores are in the 40s according to our data set? If you take a look at the chart there, how many scores are in the 40s? Here's our data set right here. All right, guys, I'll wait for you guys too. So how many scores in the 40s? I'm just gonna wait. Neon? Fernando? Okay, 1. You guys got to answer for me here. If I just sit here and just do nothing, then it's kind of boring. So I'm just gonna wait. So 1. All right. How about 50s? How many scores are in the 50s? I know you're on your phone, so let me make this a bit bigger for you. There you go. All right, 2. Good. How about 60s? How many scores are in the 60s? Okay, 1. All right. Let's keep going. 70 to 70. 70s. How many scores in the 70s? I'm not sure why it's delayed there. 5? Okay, good. Should actually be rather quick, to be perfectly honest. Here. 80s? How many 80s? How many scores in the 80s there? All right, 4. Okay. Okay. Fine. All right, 4. All right, let's put in 4. And then the last one here, how many scores in the 90s? Making sure we got that down. All right, 2. Nice. All right, good. All right, there, I hope, did that fix the delay? Maybe did that fix the delay there? I hope that did. I hope that did, question mark. The thing I don't know. I wish I knew. All right, in any case. All right. I just refreshed, okay. That's fine. Okay. All right. Okay. All right. So if we take a look here, we have a frequency distribution now. This is our frequency distribution chart right here. All right. So our frequency distribution chart right here, again, we have one score in the 40s, two in the 50s, one in the 60s, five in the 70s, four in the 80s, and two in the 90s. Okay. Now, this is not the only thing we can take care of, but again, if you add up the frequencies here together, adding up the frequencies here together, you will get 16 down here if you add them together, which is equal to the number of scores that we have here in our data set. All right. So that's pretty much how that works there in that case. Now, next, what can we do with this frequency distribution? Actually, let's go back and just take a look at this here, and then I'll bring up my paint tool here, full of this stuff. So, okay. When did I get Nightbot? Yesterday. It's not hard it's not hard with Nightbot. So I think Nightbot will take care of the modding duties, so I don't have to like look over like bad words and stuff. So it just makes it easier. Um, yeah, it's actually not as hard to it's not as hard to do with Nightbot. So I got like I have a few commands here. I mean, you could type out commands and look at it. So I have like I have a few commands. So there you go. I made up some as I went along. I put a YT. No, I think I put YouTube. Yeah. So you can see how that works. It's not hard to set up. It's not hard to set up at all. It takes very little time to do, in all honesty. So I thought it would be tougher, but it really wasn't. All right. So the next thing we'll talk about here is I'm going to copy pasta this. I need this frequency chart. I need all this stuff. All right. So what we're going to talk about next here is we're going to talk about a histogram. Yes, thank you. Next, we're going to talk about what we like to call a histogram. A histogram is basically a connected bar chart that represents the frequency distribution. Okay, so the histogram here is a connected bar chart that represents the frequency distribution. So here, if we see on the screen here the frequency distribution, well, exactly how are we going to go ahead and find out what the histogram is going to look like here with this frequency distribution? Let's take a look. So what we're going to have here on, we're going to have two sides here. So we're going to have this, and we have this. On the bottom here, we're going to have the scores. So those test scores there are going to go right there on the bottom. On the left-hand side, we're going to have frequency. Oops, helpful. So we're going to have frequency here on the left-hand side, and we'll have the scores here on the bottom. Now we're going to put in every category here. So we have 40 to 49, 50 to 59, 60 to 69, 70 to 79. 80 to 89. 89. And then finally 90 to 99. Okay, we also have our frequencies here up to 5. So we go again 1, 2, 3, 4, 5. All right, so those are our frequencies here. Again, 0 is right over here. Okay, now we want to choose 40 to 49 here. So for 40 to 49, all we're going to do here is we're going to see a bar here. Again, there's one score between 40 to 49. So you start a little bit to the left here of this hash mark for 40 to 49. Go up to 1. Cut across that hash mark. And then you can bring that back down between the 40 and 50 hash marks, just like so. So that will represent the first bar here. Don't forget that this is a connected bar chart. We're going to connect these bars here together. Okay. So here we have 40 to 49. We have 50 to 59. There are 2 of them. So we're going to go up 1 unit to 2. Start from the upper right. I'm going to cut to the right here and right between 50s and 60s. There's our next bar in our histogram. 60 to 69, there is 1. So we're going to go over here to 1. Again, starting from the left, come back down between 60 and 70, just like so. 70 to 79, there are 5. So we go ahead and go up to 5 here. Cut to the right, bring it back down. There we go. That's 70 to 79. 80 to 89, that's going to be 4. So 4 is right here, thereabouts. And so we'll bring it down here between the 80 and 90. Then finally 90 here, which is 2. So here's 2 right here, just like so. We'll bring it down there. All right, and so this is, in a sense, the histogram here for this frequency distribution. All right. Okay. All right. Are there any questions about that so far? Any questions at all? I'm not sure Fernando is here. I think he might have. I'm not sure what's going on with Fernando's stuff over there. Hopefully he's doing okay. 9? Okay. All right. Now there is a particular reason why we want to do it this way. You can also get what's called the frequency polygon. So you may see a question or so like that in the homework. So again, just making you aware here. The frequency polygon basically is a line chart of the frequency distribution. Ban that dude. All right, anyway. All right, so frequency polygon here is a line chart of the frequency distribution, okay? And so essentially you can that you can get directly from the histogram. Okay, so how do we do that here? Well, if you see these hash marks that I put out here, I put these hash marks out here on purpose. Yeah, the bots are annoying as heck. I ain't gonna lie. So here we have 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. And notice they're right smack dab in the center here. And so if we connect these, just connect them straight up as is. Here we go. This little line chart here is our frequency polygon. It's just that easy. So once you have your histogram here, it falls out pretty simple right after that. Okay, that part, honestly, not too hard. Okay, let's look at the next part here. A little bit more that we can get here from this data set. There's a couple more things here. Actually, maybe just one more part here with that. So that part shouldn't be hard. Okay, now there's one more way we can actually arrange our data here. We can also arrange our data here in a what's called a stem and leaf plot. Okay, so how does a stem and leaf plot work? Well, we're going to make a little bit of a table here once again. All right, so let's make another table. So what we're going to have here is on the left-hand side, where are you? So on this side here, we're going to have the stem, and over here, we're going to have the leaves. Now, the stem here, in our case, is going to represent the tens digit. So in this case, okay, this can represent literally any digit, but the tens digit is the most common one here. The leaves represents the ones digit. So we have scores from the 40s up to the 90s in this case. So we're going to have 4, 5, 6, 7, 8, 9. So 4 here will represent 40, 50, 60, 70, 80, and 90. So if we take a look here, what does the stem and leaf plot represent? This doesn't represent, excuse me, this doesn't represent exactly what you think it does. Let me show you what I mean. I'm going to right justify this now. And I will left justify this. All right. What this represents is we want to specifically put the values of the data set down here. So if you take a look here, the first number that you see here is 56. So we're going to put 5 and then follow that up with 6, just like though, just like so. It's just like though. So we'll have 56 here. And that's how we could, so basically we're putting the specific values of the data set instead of it making more general like a frequency distribution does. So here we'll have 78, 92, 81, 87, 99, 44, 50, we'll put a 0 there, 78. Now, again, even though 78 repeats again, we still want to go ahead and put in another 8 to represent another student getting a 78. So repeat values are okay. Okay, so let's put a note for that here. Note, repeat values are okay. All right, get 91, 75, 67, 72, 79, Again, 88 and 80. All right, and as you can see here, here is our stem and leaf plot of our data set, just like so. All right, so hopefully that isn't too bad. All righty. Any questions about that? No, it's not. But it is a way for teachers to actually take a look and see how well students did on a test in terms of a distribution. I remember there's that one dude who basically used this in order to determine that his students cheated. So now, am I saying you guys cheat? I mean, it is what it is. But um, teachers don't grade this way. I don't grade this way. But if I want to see how well people did, then I can take a look at this data set and I can see exactly how everybody did as a whole. So it definitely does work. That's why data collection is very important. You can actually make easier conclusions here once you organize your data and then apply it to what you want to be looking for. So um, if there's one thing that statistics can definitely show you is like, hey, yeah, that the trends that they talk about often, it's supported by the numbers that you get in the data. So if you get access to the raw data there, then if you can apply it yourself and see exactly how that works out. The last point in this particular section, by the way, is they talk about how to kind of be careful about graphs and stuff like that. Like I'll show you what I'm talking about here. This see if I can go to the e-text here. There's a particular page I want to show off here to you, since you're here. I hope Fernando's okay. So hopefully he's doing okay. All right. So there's a lot of ways that graphs can be very misleading. For example, just because of scaling and whatnot. That's certainly one thing you have to be careful about. Like for example here, if you take a look at 35 with this pie chart here, the pie chart here should represent 100%, and yet the US is represented as 29%, but takes up half the pie of the chart and is elevated compared to the other countries, which again is not true. Okay, again, yes, the US is separate, but not by the significant amount that you think it is based on the visual that you're given. That's kind of like the important part there. Um, that's kind of like, so like I was saying here, like if you take a look here at this, okay, what's the tough part here to see? Okay, the difference between 190,000 and 172,000 is not as great and significant as you can see here by the visual in the chart. It just doesn't make much sense to be a thicker book and a taller book. 190,000 is not too far off from 172. So to say that it's that much off, it's kind of a poor scaling thing. Let's see. What else? Here we have another chart which looks like it goes up linearly. The issue that is with the global population is that notice that the amount of years between each of these, um, kind of is different. It's not like every year. It's basically every, you're like, okay, hey, here you go. 1804 to 1927, 1960 to 1974, and so on and so forth. So you can tell how that works. So just have to be careful about visual representations of data. Okay. All right, Neon. Any questions? Any questions about today? No? Okay. No problemo. Excellent. All right. So this is where I'm going to end off here for today. Okay. Thanks for coming out here and sticking around. Like I said, I hope Fernando's doing okay. I know he gets frustrated that I use Twitch, but um, yeah, hopefully he'll be all right. All right. So yeah, that'll take care of it for today. And we will see you again on we'll see you again on Wednesday. All right. That's section 12.1. Get prepared for more at chapter 12. All right. All right. Very good. Remember, the test is due on Friday, so don't forget about that. All right. Be sure to practice with that and work on it. All right. Okay. All right. Take care of yourself, Neon. All right. And we will see you later. All right. Have a great day. Enjoy. If you haven't had lunch already, enjoy your lunch. All right. Have a great one. We'll see you, buddy. All right.